Hello and welcome back to post analysis of Job-A-Thon on Geeks for Geeks. So we are having with the very first question, that is nothing but find the final array. So what is happening in this question? Just read the question statement. Given an integer n and an array b of n elements, we have to perform the following operations for each and every element while traversing through our element. So we have to choose the first operation is we have to choose an index I, and we have to store its -1 to some variable num, and after it for the second operation we have to add that updated num into our next element. Now, what we have to do after it, we have to either decrement the we have to do both the operations and decrement the number by 1 and increment the index by 1 until we have to repeat these operations until we are not getting either number equals to 0 or I greater than n, or I update out of its bound. So let's assume what is the test case. So test case is n equals to 5. The very first test case is n equals to 5 is given, and the array is 5, 4, 3, 2, 1. This is our array. Now what we are doing, we have operations. We have to choose index element. So let's start for the very first index. Here they are using the concept using some temporary array filled with all zeros, and we have to do the operations on that such that whatever will be the updated array, we just add it to our original array corresponding values, and we got the answer. So let's discuss the very first test case is nothing but firstly use temporary array of all zeros, that is C here. So let's assume that 5 size of array filled with zeros. Whatever the operation we have performed on on the original array will not perform on that. We have to perform out on the temporary array such that at last we can merge them. So what will happen? Now choose index 0 element. Now we just choose the index 5, index element 5. So 5 is the array value. What will the value of be our array of I, that is 5? Store into number. Number will become 5. Now what is the operations? We have to decrement by 1. We have to decrement by 1 and we have to store it our num. Now what we'll do after the second part, add that number into its next index. Add that number into its next index. So our next index is second index, that is 1. So we have to add that number into our second index. So 4 will be added. Number equals to 4. The value of number equals to 4. So it will be added on the second index element, that is 4. Because of zero based indexing, we have to add it on first index. So now do what? We have to decrement our current number by 1. Just decrement it. Number become 3 after decrement. And what we have to do? Increment in our current index by 1. So currently we are on the second index element, that is I plus 1. Do what? Just update it. Now again we have to update it. Now we have to encounter with the next element. What the fourth operation is? Repeat step 2 and step 3 until I'll not get the either greater than n or number equals to 0. So what is the second operation? We have to add current number, whatever we have stored in the number, just add it into next integer element, next element of array. So next in element is next index is to second index, so that is 0. Just add that number is 3, the updated number is 3. Just add it into the next value, that is 3. So 3 will place here. Now do repeat the second and third operations again and again until either you exceed the n or your number becomes 0. So now update the number. Number now becomes 2. Your number will become 2. Repeat the third operation. What is it? Add the repeat the second index, second operation, that is number to the element I, because we are now update our I with I plus 1. Now we are dealing with the third index element 0 1 2 3. So third index element, that is 0. Now what is this, what is happening here? So we have to do what? Just add that number into our that element, index element. So index element is 0, just, and number is 2, just add it. Now again repeat the next element, that is index by 1 plus and number by 1. So now number become 1, and your well I plus 1 become the last index element. So do what? Do add it. So 1 will come here. This this is the resultant array after we have performing the operations on the first. If we choose the first index element, that is I equals to 0, this is our updated array. So for I equal to 0, our updated array will be 0 4 3 2 1. This is our updated. Now choose I equals to 1, perform the same operations. Our original array 5 4 3 2 1. This is our original array. Second index element I equals to 1, that is 4. Add 4. What? Perform the second operation. First operation is add the current index element into num by 1, into num by 1. So 4 will become 3, 3 will become, now add 3 into our element, whatever present into next element, whatever present into next element. So now we are encountering with the second index element, that is I plus 1. Because I is 1, now we have to perform from I plus 2. So what is I plus 2? It is already filled with 3. And what is the value of num? Num is 3. Just add it. So 3 will become 6. Similarly, now 3 will our number become 2 after decremented by 1, and I plus I becomes I plus 1. So I will go on this pointer. Now what is the value there? That is 4 or 2. And what we have to add? What is the value of number? It is 2. Just add it. Then do num minus minus and I plus plus. Do again. So the last value would be 2, because that num become 1, and already 1 is present. 1 plus 1 would be 2. This is for I equals to 1. Now for I equals to 2, do the same. What is the value? 3. 3 minus 1, that is 2. Where here I have to perform from I plus 2. So till value, the operation would be 2, same. So 2 will be added our current element, that is now 4 will become 6, and 2 will become 3. Now do what? For I equals to 3, our array will become 0 4 6 6, and what is I equals to 3? 0 1 2 3. 3 equals to 2. 2 will become 1. The value of number becomes 1. Now add it into our element, whatever the present. The 3 is there, the 3 will become 4. Now for I equals to 4, we our array would be same, because I, there is no I plus 1 exist. There is no I plus 1 exist. So we don't have to perform further. Now this is our resultant array. This is our resultant array. Do what? Just add it into, just add this into our original array. Original array would be 5 4 3 2 1. Add it with the corresponding values. So our resultant array would be 0 plus 4 plus 6 plus 3, 6 plus 2, 4 plus 1. So that is become 5, that is become 8, that is become 9, that is become 8, and that is become 5. So this is what we are having our output. That is what we have to do. Now whatever it written here can be checked with the our test case, the constraint. The constraint is n equals to 10 to the power 6. But the question is, already is given the sum of n over all test cases won't be exit 10 to the power 6. So we can simply solve it with the brute force solution. Whatever is written here, just implement in our code. So this is the code which I written in our C++. So answer is my resultant temporary array filled with 0. Now do what? Pick the current index element and add it into our num, that is x. I am using x. And what is the value? What is the index of it? I am using j as the index. J will become I plus 1 because we have to add that number into I plus 1. Now do the same, perform the next elements, next part. For I equals to 0, we are getting this. Just add it to the second, the next element, add to the second element, after updation, add to the second element. Just do it. So till I am in the range j less than n and we our number is greater than 0. Just add that number into our temporary array and do what? Number minus minus and index plus plus. And in last, just add those values into our resultant array, that is answer 1, and just print it. So this is our the first question. Now this is our first question. Now we can further move to the second question, that is best price. Firstly, read the question. So question is given: Geek yesterday found a diamond in his garden. Since his family needs money, he wants to sell the diamond, but he is unaware of at what price he should sell it. So he consulted his n friends, and each friend gave him a range of low to high, which can be the price of the diamond according to the friend. According to the geek, a price is that is suggested by at least k of his friends is considered to be best. Since geek is the very curious child, so he asked himself q questions such that where each question consists of two values l and r represented as l comma r, such that how many prices in the range from L to R, both L and R are also included, are best according to Geek. So this is the question. Whatever the question statement until here is nothing but Geek is one of the guy. He got some diamond into in his garden. Now he want to sell, so he consulted with some n friends. What at what price should I sell the our diamond? So the friends of his just suggest him some range of the elements, some range of the price, so that he should sell his diamond. So basically, given is uh, price I would be the low and high. So every index element denotes the what is the price suggested by the first friend, second friend, third friend, and so on. And the low and high is the range which he gave, which he suggested to geek. Now what happened? We are also have the 2D integers of arrays queries, which where queries I equals to l comma r, which denotes that if geek fix the price in the range L to R, then how many prices in the range are best? So how many prices in the range are best? The length of the queries is q, and at least we are also given an integer k. We are also given an integer k. See everyone, in the queries, whichever the price are common to all of the geeks, and it is greater than equals to integer k. That means the frequency of that element, if that greater than equals to k, so there are that prices geek have to sell their diamond. So your task is to return the integer how many values whose frequency is equals to or greater than k. At least at last we have to we are also given the integer k. So which element represent the query answer? So let's discuss the very first case, that is 1 comma 3 and 2 comma 4. So this is price suggested by two of his friends. So k equals to 2. So let's solve the test case. So n equals to 2 is given in this problem. Now Geek is having two friends. He suggested with two friends. One tell that that the lowest price he should sell to 0 or 1, and the highest price he should sell to 3. Just fill the between values. And the second suggest him that his low price is 2 and high price is 4. So this is what a geek have to do. So now at which price he should sell such that k equals to 2 is given in this question as price 2 comma 3. So geek have their mind if let's say how many of them in their friend circle suggested the which price is common among them and it has the frequency at least k. Geek friends suggested some prices to him and with low and high. So Geek having some mind, he concluded that how many numbers are in between are having the frequency with at least k. So this is the price suggested by his first friend. This is the price suggested by his second friend. The low and high, then the low and high. Now do what? What? Just combine the frequencies. So 1 is with 1 time, 2 is with 2 times, 3 is 2 times again, and 4 is with 1 time. This is the frequencies of elements. This is the frequency of prices suggested by his friend. So if how many of them are having at least k times suggestion. So he just thinking how many of the prices suggested by his friends whose are frequencies of the price is at least k. How many prices are there whose frequencies are at least k? That is the simple part of the question. Now, this is the technique uses here is nothing but sweep line technique. Sweep line technique is used here. Now, what is sweep line? It is nothing but it checks the first value and check the second value, and if there are having some common, it just combining it. Now, what is happening? So his friends suggested some values, that is nothing but 1 and 3, and second is suggested some 2 comma 4. What is the approach I am using here? Just do what? Write the frequencies and mark the low frequency with +1 and the and next to the high frequency. What is the high frequency is 3. Whatever the next element is, that is 4 is there, just mark its frequency with -1, that is +1, and that is 5 with -1. Now combine it. 1 will come with 1 frequency, 2 will come with 1, and do what? You just do the prefix sum of frequencies. Just do the prefix sum of the frequencies. So 1 is there, 2 plus 1, and plus 1 that is 2. 3 is having no one. 0 is 0, 0 mention is there. So 0 plus 0 is 0, and what is the prefix sum? That is 2. So the prefix sum of 3 is 2. Now for 4, 0 minus 1, 0 minus 1 and plus 2, what it would be? 1. So update it with 1. And for 5, it is nothing but -1. So just leave it for the 5. So this is our prefix sum of frequency array. This is the hint in this question. Now just check over the queries, whichever having the uh, part is matching. After it, when you done with the frequency array, calculate one more time whose frequency is greater than equals to k in our frequencies prefix sum, and do again prefix sum. Do again prefix sum. If the element in our prefix sum is greater than equals to k, just add it at, and if not, then do the previous one. That is, 1 is there, 1 is not greater than k, so it is 0. So here 2 is given. 2 is given, 2, the frequency of 2 is 2, so it is greater than equals to 2. That means count plus plus and add it to the prefix sum. Prefix sum is 0 plus 1, that is 1. Now again is what? 2 is, again 2 is given. So count become 2, and having the prefix sum is 1. If the current frequency element is greater than equals to 2, then 1 will be written and added to prefix sum. Then for answer 3 it will be 2. For answer 3 it will be 2. And for answer 4, count is 0 and previous is 2, that is 2 is given. So now your frequency array, above is the frequency array, and the next array is filled with how many of them are having frequency array greater than k with the prefix sum. Why are we using prefix sum? Why? Because we are having some, we have to perform some operation on queries. If we got the array filled with some values, and in the prefix sum, the in the prefix sum questions, what we are doing, we are hinting with, the hint is prefix sum in them in the queries part. And if we want to just find what is the sum of L to R, we use prefix sum as the trick. So here we are doing the same. We have to find how many frequencies are between L to R who are greater than equals to k, at least k. So we are just doing nothing. We are adding the frequencies with in the prefix sum, and the resultant array is frequency array of prefix sum whose frequency is at least k. So now our resultant array is filled with 0, 1, 2, 2. Just perform the query. Now if we want to find the how many of 1 till 4, how many of them are having queries in between, we have to answer the queries. The length of the query, how many of prices are in the range are the best. So best price is whose frequency is greater than k, greater than equal to k, and we have to calculate how many prices in between till 1 to 4, how many of them are best in them. So it is nothing but do the same. Just check it directly with on the arrays. So we are having one array of prefix sum frequency. Then if we got the L and if we got the R, we can simply calculate how what is frequency in between by doing frequency of R minus frequency of L minus 1. That is what we are doing if we want to calculate the sum between the range L to R. We have to do the same. So let's implement in our code. So we are firstly checking the maximum. We are just to store what should be the maximum part. So maximum part is nothing but we are having the frequencies ranges 1 till 3, 2 till 4, and let's say 5 till 6. We have to do this. So we have to calculate one number, we have to find one number such that we have to make our firstly the count array, and second the prefix sum array of frequencies of original frequencies of frequencies greater than equals to k. So this is what we have to do. Now what we are doing, we are just finding the at what length we have to initialize our counting frequency. So just traverse over original array as well as our queries. So we are doing the same. Mx would be my, what is the maximum number among the all combination of my array with frequency with low and high as well as in the queries part. So now we are making the count as our maximum size of counting frequency number. Now what I am doing, I have 1 till 3, then 2 till 4. I am adding the plus 1 at the low part and minus 1 at the next part of high. That is at the fourth, it is minus 1. Plus 1 at the first part, minus 1 at the its next element. Plus 1 at the first index, minus 1 at its plus 1, minus 1. So now I am doing after it whatever will be the counting of frequencies, whatever will be the counting of frequencies, I am doing prefix sum of it. 1 is 1, then 2 is nothing but 1 plus 1, that is 2, then 3 is 0, 0 plus 2, that is 2, then 4 is minus 1, 0 minus 1 plus 2 is nothing but 1. So after it, 5 is there, 5 is minus 1 is there. So minus 1 plus 1, that is 0. So in the resultant array, our resultant frequency array, it's none other than how many numbers are having, which numbers are having frequencies. So we can simply say 1, 2, 3, and 2, 3, 4. 1 is come with one time, 2 is happening with two times, 3 is also with two times, and 4 is one time. Rest 5 is 0 times, 6 is 0 times. So this is the frequency array we can get by doing, by adding the plus 1 and its next element with minus 1. So we can simply get the 1 2 to 1 our frequency array. Now we are in the second part, we are doing only, we are adding those frequencies in our prefix sum whose frequency is at least k, whose frequency is at least k. So our value val array will store only those prefix sum numbers whose frequency is greater than k. So those counting numbers is greater than equals to k. We are denoting count value will give either true or false, or you can say 0 comma 1. It will give 0 comma 1, and we are adding it to our prefix sum of frequency array who is greater than equals to k. Either it will give 0 or it will give 1, and we are making the frequency array of those elements which are having frequency with greater than equals to k. Now in last, we are doing the normally range what how many of them elements are having frequencies at least k. At least k, we are just checking whatever in the first, whatever in in the second part, and we are just checking into our well is none other than our frequency of at least k. So this is the code which I am running. This is the approach of my question. So just run it and just complete it. Till now, we just solved very first two question of Job-A-Thon. Now just move forward to the next question. That is, just read the problem statement. So that statement is special subarrays. Question name is special subarrays. So we are just read the question statement. We are given an integer array of size n. Your task is to count the special number of subarrays of a given array. So here a subarray of size L to R to be special if it is satisfying the golden condition. The golden condition is nothing but the subarray, the maximum among from L to R, and the edge part, that is and the corner part, that is array of L minus array of R. The absolute difference of this part should be divisible by k. So we are having our first test case, that is 5 7 2 4. Let's say k is 2. So the question it states that maximum of L till R minus array of L minus array of R. The absolute difference should be multiple of k. That is we have to solve in this question. So we have to calculate how many subarrays are there which satisfy the given condition. So here is the maximum of subarrays, maximum value of the subarray, and that refers the absolute difference. So let's say this is the very first example. Special subarrays 5 7 2 4. K is given, that is 2. So the possible subarrays of this question, this part is nothing but one is 5, one is 5 7, one is 5 7 2, other is 5 7 2 4. Second is 7, then 7 2, then 7 2 4, then is 2 and 2 4, and then 4. These are our possible subarrays of the given array. Now we have to calculate the R, and the very first array is nothing but the rth element is 0, and the first element is L is also 0, maximum is 5. So array of L is 5, array of R is 5, and maximum is 5. So what is the maximum absolute difference is 5. So can we say 5 is a multiple of 2? No, no. So we can simply say that this should will not contribute our answer. We have to calculate 5 and 7. Can we say what is the maximum is 7, what is the L is 5, what is the R is 7? What is the absolute difference, what is the absolute value of this part is 5? Can I say 5 is multiple of 2? No. So this is also not contributing. For the third subarray, maximum is 7, L is 5, R is 2, which is 0. Can I say 0 is a 0 mod k, 0 mod 2 is equal to 0? Yes. So this should be contributing in our answer. So we can simply say count plus plus. For the last for this part, this subarray, our maximum is 7, our L is 5, and our R is 4. Can I say 2 is a mod multiple of 2? Yep. So this will also contributing. So count plus plus. Now for this part, 7 is there. 7 minus 7. No. 7 comma 2, 7 minus 2 comma 7. Yes. So count plus plus. 7 to 4, that is 7 minus 2 minus 4, that is yes 4 divided by 2 equal to 0. So count plus plus. For 2, yes, count plus plus. For 2 4, count plus plus. For 4, count plus plus. So at last, how many count is there? 1 2 3 4 5 6 7. So the very first test case is having, for the test case is 5 7 2 4. Our count is 7. 7 is the answer. So in this question, the very first hint in this question is to use the divide and conquer till we have to split it into the very last element. So our array is 5 7 2 4. Just do one thing. Firstly, make the remainder array. Remainder array is we are using just to check which will contributing. That means those who are having the frequency 0 those who are divisible by k, we just add it to we just that element should contribute here. And what and we are using one more array, that is frequency array, which will calculate the count till I. So we have to, in last, we have to just calculate the frequency part. Frequency array will contribute in the counting part, while remainder array will calculate the which element should contribute in our answer. So just do one thing. Just firstly do the divide and conqueror. Firstly, just make the remainder array. So remainder array is nothing but 1 1 0 0. Now our resultant array is 5 7 2 4. This is our array. And it result and our remainder array is 1 1 0 0. Divide and conqueror it. Divide it. Firstly divide it, and then conquer. The first element is 1 1, then 0 0, and again do from mid 1 1 0 0. After it, we know what is our right, what is our left in when we are denoting it. And do one thing, those are 0 when our left equals to right. If we are just using the divide and conqueror at any point, what is our base condition? When our L and R same, at that point, what will be in the remainder array? Just do one thing, just change which is 0. If it is 0, then update it with 1. So if remainder array, in our remainder array, if remainder of L equals to 0, if it is 0, update it with 1. Remainder of L would be 1. If it is not 0, then denote it with a 0. So we are now dealing with the values. Now our updated array of resultant, is basically filled with 1 or 0. Why we are doing this? Not on the same part, just to find the what base condition at which point we should remove. You can do in the original part, but you can do in the divide at the time of divide and conqueror. So now our array elements 1 1 0 0. Now the time is to combine it. How you are combine it at that point such that your frequency array, you have to check on the left and right half. After you are combining the left and right, just check it with our just check it if there any index is there which is greater than our right. So combine it in that way according to the maximum. So what should be the maximum in the left half? You should keep track of that index. What is the maximum? You have to keep track of that number, which is the maximum. And why we are why we are storing the index of maximum part? Because it will contribute in our answer. What is the problem statement state? It's maximum of L till R minus array of L minus array of R. The absolute part should be divisible by K. The absolute part should be divisible by K. So we need to find the index of the maximum element in the left half as well as in the right half first. So just calculate in the left half. For in the left half, and there are right half. There are two halves will be there. Left and right will be there. Do one thing, at the time of merging, at the time of combining, you have to calculate, you have to update it into the frequency. If there any value in the left and right when you are combining it, if there any value in the left and right, if that is maximum, it will contribute to its next element also, and it will contribute to its next element, because you that element is maximum. So you have a track of maximum index and what is the and as well as the maximum value in the left half and right half. If you are combining it, just check for the next values also till till you are in the range of R. So when you are combining it in 5, 7, 2, 4, when you are combining it such that when you are combining for the 5 and 7, your index is 0, 1. Your mid value is 0, comma 0. This is for the left part, and your index is 1, comma 1. So R is 1 and L is 0. This is for the divide and conquer. At the time of divide and conquer, these are the mid, uh, and mid is 0. When check in the left half, when you are combining, if your mid plus 1 is nothing but the temporary index. You should keep track. Firstly, you are storing the index of the maximum element in the position number. Let's say this is the position, and mx is storing the maximum number of till in that uh, quadrant, in that quadrant, whichever you have to solving. And your you are doing what? You have to use some answer part which is based on either 0 or 1 plus 1. It will do this part because answer is giving the resultant answer how many sub-arrays are there. This is nothing but counting part. So answer, we are using integer of answer, which will on the left half as well as right half. And in the question it is also given mentioned that the answer could be as much as possible, so it is 10 to the power 9. We can further use our mod to how we can store it, how we can calculate it. So our answer is storing our left as well as right half. Now when you are combining it, we are using divide and conquer. When we are at the time of combining, uh, we know the position of max element, we know the what is the max element. Just check in the right. Let's say in the when you are combining the left half, you are having some left value and you are having a right value. Just check from mid plus 1 till R. When you are combining the left part, just focus on this part. When you are combining on the left part, you have to know what is the maximum element, what is the maximum element, and start a temporary pointer from mid plus 1 till R, as well as when your array of mid is less than equals to max. If this condition is true, that means our next element also have some pre-computation from the previous element, because previous element is maximum. Because previous element is maximum, we can simply say for sub array 2 till 2, 7 is playing the important role. So for 2, 7 is also playing the important. So 7, we know that part. So in the left part, just you are just starting from mid till L, and you are checking the checking what? Checking the what is the maximum till that point, till I. What is the maximum till I? So after it, at the time of combining, you are calculating it. You are having the three values. What is the maximum? What is the its position? And why I am doing to check at the right part? Why? Because our frequency array is counting the numbers, how many times that position will contribute in our answer. So frequency array will keep track how many times it will contributing in how many sub arrays. So this is the logic part. for the frequency array. Now, when at time you are getting with position of the maximum part, whichever the point you are standing for the 5 comma 7, you are now checking for the 7, and the position of maximum is nothing but 1. So position of the maximum, if array of position minus array of I, this will also in the contribution part of array of R minus array of L, and your maximum part. Array of position is array of maximum minus array of I. This is what max of array from L till R minus array of 1, either it be L if you are combining from the left part, and it will be right when you are combining on the right part. So this is the approach. Let's focus on the code part of it. So we are firstly making the frequency array to keep the track till 0, and I am using the remainder array which will uh, use either 0 till n minus 1 in values in it. Now I am calculating our divide and conqueror. So I am just declaring my remainder array and my mod part, because how my our answer should be as much as possible. Now our base case is 2. If number is divisible by k, we only keep track for that element to 1, else we are just doing the 0. So after it, we are doing the again divide and conquer on the left part, or divide and conquer on the right part. Now use the mod to use the whatever we have to calculate. Now we are just checking for the left part. Mid till IL, what is the maximum till I? And I am checking for the right part. If it is in the range, if the value is still less than the maximum part, that element in the sub array from maximum till that, or you can say previous till that element should also have the impact of the maximum value. So we are just updating it, and we are doing our frequency plus plus to keep track whether the element is contributing or not. So this is to what. And last, we just note the what is the maximum part till I. So here, what is the maximum maximum till I, and what is the part of your L. So this will calculate the part and check if this is also modulo k according to question. Maximum of till R minus L, R till L, and array of L. If this is divisible, we have to use it in some part. And let's say it's the what is the value in the remainder array. If it is less than k, so if it is less than k, we just add k more to keep it positive, and our answer is the total count. And it is coming up with the current count comma frequency array, frequency of R remainder. What is remainder? It is remainder of this part, because in last we have to calculate from a maximum of L minus L till R minus array of L. This is array of L for the left combining, and array of R for the right combining, and we are doing plus k to make it positive, because we in the original question we are giving with the absolute part. We are giving the with the absolute part, but here we are using the firstly remainder array to keep track which element is contributing. And when we got the negative, we just adding the plus k into that element, so that we can get it the positive value. So thank you everyone.